Gang, stuff's getting real now, I guess. We're going to go over the midterm study guide. And this, really, study guide for the midterm just really depends on how hard you've worked so far. Some people like to just kind of fart around, just put all the work in the end. That's called a procrastinator. My wife's one of the biggest ones I've ever met, but she does it well. And I'm even kind of the same way. But, some people like to be more persistent. So, people have different personalities. So, what I got going on here's the way I want you guys to do this. I know that ultimately you're going to do it however you want to do it, but what I have here is I have 3 pages, and I am going to show you all 3 pages. And what I highly recommend to you is that you take screenshots or whatever, and you try working all of these 10 problems, and then you watch the video of the solutions. Because, guys, we're at a point now where we should be good at this stuff, because you got an exam here within the next few days. So kind of put yourself to the test. How would you do on this? And don't beat yourself up if it's not so good. We can get better. So, guys, there is page 1. And there's page 2. And, somewhere is page 3. And there is page 3. So there's 10 questions that you can do screenshots of that you can put yourself to the test to see whether or not. I learned long ago, both as a student and as a professor, that math isn't a spectator sport. You got to get in and get your hands dirty. And if you're going to sit back and watch something be done and trick yourself into thinking that you know how to do it because you can watch me and I do it and you so-called understand what I'm doing, you really don't understand. It's not about whether you understand what I'm doing. It's whether or not can you do this on your own. And this is college. It's all about learning independently and all this stuff. All right, gang. So hopefully you'll pause. You'll try to work through the 10 questions, and a couple of hours later you'll come back and start to hit play right now. Okay. So, question number 1, what did you do? Well, the first thing I would do in question number 1 is, I'd start the problem and set it up. All right. So I would set it up the following way. It says, in the United States, the total alcoholic beverages and sales were 119.1 billion in 2013. 132.3 billion in 2005. Let T represent the time in 2003. So we know from problem number 1 that we know that A of 0, which is equal to 2003, was 119.1 billion. So these answers are all going to be in billions. And we know that 2 years later that we have 132.3 billion. Okay? So T equals 0 corresponds to the year 2003. So for obvious reasons, this stands for 2003, this stands for 2005. Now, from this, what we can do is we can create order pairs. So we know 0 goes with 119.1, and we know the 2 goes with 132.3. And I would use my graphing calculator here to get those values, as I've taught you before. So, I would go to Stat, and I would put in 0, 2. And I would put 119.1. and 132.3. All right, just like before, I'd go to stat. Well, I'd go second function quit. I'd go to stat. I'd go over to calc. I go down to number 4. And I would have L1, L2. Now, what I get here is I see that my slope is A, so my slope is 6.6, and I see that my intercept is B, and my B is 119.1. So, gang, when I go back over, I can see that my function will be A of t. I'm going to write this down before I get back over there. All right, now let's get back over here. All right, so that's my function, and that's what part A asks, is find a linear equation that represents the amount of alcohol. So guys, here I would have A of t equals 6.6 t plus 119.1. Now, the next question says estimate the alcohol sales produced in 2015. Well, guys, 2015 is 12 years past the starting point of 2003, right? So essentially what I want here is I want A of 12, because again, 2015 is 12 years past the beginning start, where we have t equals 0 corresponds with 2003. So I would have 6.6 times 12 plus 119.1. So put that in your calculator. And I get 198.3 billion. It was billion, yeah, okay. So if the model remains accurate, which it probably won't, I think a linear model would be horrible to represent this. This would be something probably more representative of an exponential, or even probably, well, actually probably more logarithmic, but we didn't study that. So anyway, as a linear function, if the model remains accurate, then then when would alcohol sales reach 200 billion? So gang, what we need here for this problem is we need to know when does our function for what t does it reach 200? Well, this should be really easy to you by now. We're going to subtract 119.1 from both sides. So we get 80.9 on the left side, and we get 6.6 t on the right. Of course, we're going to divide both sides by 6.6. So our time is going to be 80.9 divided by 6.6. So this is about 12.3 years from 2003, which is our beginning. So add 12 years to that, and we can say that this is approximately going to happen in year 2015. Okay, so that should have made a whole lot of sense actually, because and that's what I was. So sometime in the year 2015. That should make a lot of sense too, because when would we reach 200 billion? Well, we saw that we'd reach 198.3 billion at the start of 2015. So it doesn't stretch the imagination to say that we would reach 200 billion sometime in the year of 2015. All right, number 2 is a kind of a harder problem. I want to work it completely because we're kind of at crunch time. So let's do this. It's going to be a lot of questions on your midterm about cost and break even and profit function, revenue function stuff. So you're going to have some of this, okay? So I'll tell you what, let's do this. I think this is going to be better. All right, so all right, so at a break-even point of 500 units sold, what does that tell me? Break-even is when my revenue function equals my cost function. So I know at 500 units that my revenue is going to be equal to my cost because that's the definition of break-even. Now I got a little bit more information here. I know that the variable costs are 125 and the fixed costs are 10,000. So I know that my cost function is this. Now the next thing, what will the 501st unit sold contribute to profit? All right, so what do we know? Well, we know that C of 500 is involved in this problem somewhere, and we have this cost function, so C of 500 is going to be easy to find. And it looks like to me that's 72,500. So I know that C of 500 is 72,500, so I can replace C of 500 with that amount. So I know now that the revenue from 500 units has to be equal to 72,500 because we're breaking even there. Well, I know the revenue function is some price times the quantity. And I know that quantity has to be 500. So the price at which this item is sold is $145. So gang, that tells me that my revenue function is 145 times Q. All right, now is 145 times 500? 72,500 it is, which just kind of validates what we have here, okay? Now, our profit function is going to be the revenue function minus the cost function. Well, our revenue function is 145Q, and my cost function is 125Q plus 10,000. So ultimately I have 145Q minus 125Q minus 10,000. So my profit function is 20Q minus 10,000. So what is this right here? This is my marginal profit. This tells me the additional profit I get for each additional unit. So go back from 500 units to the 501st, which is one additional unit. The additional profit is going to be $20. You get that from your profit function. Guys, you're going to have one of those. Be prepared. All right. All right, number 3 says 3 species of bacteria are fed 3 foods, foods 1, 2, and 3. Weird name for foods. A bacterium of the first species consumes 1.3. Now, you know, we can look at this and we can already get the feel for number 3. This is either a systems of linear equations or it's a linear programming problem, because these are the 2 types of problems that set up like this. A linear programming problem is going to have those magical words max or min. Systems of linear equations are just going to ask you to solve for something that comes up with some given conditions. Well, as I look down through here, I don't see anywhere in here that I read this problem, and I read it earlier, where I'm asked to find a max or a min. So this is going to be a systems of linear equations. Now, what did I tell you in previous videos to do here? Go to last sentence and see what they're asking for and create your variables accordingly. So if yada, 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 okay, how many of each species can be maintained in this environment? Okay, so we have 3 species of bacteria. So I'm going to call X equal, so how many of each? The number of species number 1. Y is the number of species number 2. And Z is the number of species number 3. All right. Now, we know that the bacterium of the first species contains 1.3 units of foods 1 and 2, and 2.3 of foods 3. We come on down here and we see that 16,000 units of food 1. So we need to get the food 1 from the first species, the food 1 from the second species, and the food 1 from the third species. All right, so I'm going to circle this. So a bacterium of the first species consumes 1.3 units of food 1. Bacterium of the second species consumes 1.1 of food 1. And a bacterium of the third species consumes 8.1 units of food 1. And the total of food 1 is 16,000. All right, same thing. Try to get this where you guys can see it, and me too. All right, the next thing we're going to get into is we're going to get into food 2. Well, the first species contains 1.3 of food 1 and food 2. So we're focusing on food 2 now. So we know food 2, if we come on down here and cheat a little bit, we know food 2 is 28,000. So we want the food 2 from each of the species. So second species has 2.4 of food 2. And the bacteria of this 2.9 of food 2. All right. Next thing we get into is food 3. So bacterium of first species, food 3 is 2.3. So let's see what happens with the second species. And let's see what happens with the third species. And this is going to add up to 44,000. All right, so in essence what we did is we created a inequality for each of these for food 1, food 2, and food 3. Well, I got a phone call from Santa Ana, California. Probably wanting to give me a cruise or something. Seems like I get one of those about every day. All right, gang, what I want to do now is I want to put this into an augmented matrix. I'm not going to write all this down. We should be, pretty good at this stuff now, but I am going to demonstrate it on the calculator. Okay, so gang, let's grab the calculator. I'm just going to use the one here. Trying to go back and forth between calculators. So go to matrix, go over to edit. Now it just so happens we need a 3x4. And start carefully typing numbers. So I have 1.3, 1.1, 8.1, and 16,000. Line 2 is 1.3, 2.4, 2.9, and 28,000. 2.3, 3.7, 5.1, and 44,000. All right, just like before, make sure that's entered. Second function, quit. Go back into matrix, go over to math. I scroll up because it's closer to the bottom than it is the top. Go in and get your matrix. And we get our following. So we're going to have 9.7, 10,128.2, and 224.4. Guys, I know when it comes out like this, where it's not nice, neat numbers, that it's kind of freaky, especially when your grade's at stake. I'll do my best on your assignment to come out with numbers that turn out like, 2, 2, 3, whatever. I mean, there won't be the decimals. So, but I actually did. I think I said in here, round to the nearest whole number. So I didn't even follow my own. So this should be 2340. This should be 10128, and this should be 224.